Welcome to aminacademy.com. In material science and engineering, let us discuss about crystal system. Since there are many different possible crystal structures, it is sometimes convenient to divide them into group according to unit cell configuration and or atomic arrangements. One such scheme is based on the unit cell geometry, that is the shape of the appropriate unit cell parallelepiped without regard to the atomic position in the cell. Within this framework, an XYZ coordinate system is established with its origin at one of the unit cell corners. Each of the X, Y, Z are coincides with one of the three parallelepiped edges that extends from this corner. On this basis, there are 7 different possible combinations of A, B, C and alpha, beta, gamma, each of which represents a distinct crystal system. There are 7 crystal systems and they are named as Triclinic, Monoclinic, Orthorhombic, Tetrahedral, Trigonal, Hexagonal and Cubic. The relationship between 3-dimensional crystal families, crystal system and lattice system is given in the following table. First one, cubic crystal system. The cubic crystal system is a crystal system where the unit cell is in the shape of a cube. It's one of its most common and simplest shape found in crystal and minerals. Cubic crystals are characterized by 3 mutually perpendicular axes that are equal in length. All 3 angles intersect at right angles and are equal lengths. This ABC equal, alpha, beta, gamma also equal. 3 main varieties of cubic crystals are primitive cubic, also called simple cubic. This is one of the 3 main common representatives of cubic structures. Second one, body-centered cubic, abbreviated as BCC. Next one, face-centered cubic, abbreviated as FCC. This structure has atoms at each corner of a cube and 6 atoms at each face of the cube. The atoms are packed as tightly as possible. Metals that have a face-centered cubic structure include copper, aluminium, silver, gold, nickel, platinum and gamma ion, also known as austenite. Next one, hexagonal crystal system. The hexagonal crystal system is a crystal system with 4 crystallographic axes. Includes 3 equal horizontal axes and 1 vertical axis. The horizontal axes are equilateral and intersect at 120 degrees angle to each other, while the vertical axis can be longer or shorter than the horizontal axis and is perpendicular to them. The hexagonal crystal system has 6 sides, with 3 sides being equal in length and meeting at 60-degree angles. Look at this figure for hexagonal crystal system. The hexagonal crystal system can take several forms, including prism, pinacoid, dipyramid, tetragonal pyramid, trigonal prism, and tetragonal prisms. Minerals that can form in the hexagonal crystal system includes apatite, beryl, taphite, and zincite. Next one, tetragonal crystal system. The tetragonal crystal structure contains 3 axes and the central axis has a different length, either shorter or longer than others. The other 2 axes are in the same plane and have the same length. The tetragonal crystal shape includes double and 8-sided pyramids. Double and 8-sided pyramids, 4-sided prism, pyrite and trapezohedrons. The tetragonal system has simple and body-centered tetragonal cells, and Bryce lattice follows the given relation. Here A, B are equal but not equal to C. Alpha, beta, gamma are equal to 90 degree. Here you have to say A equal to B not equal to C, and alpha equal beta equal gamma equal to 90 degrees. Tetragonal crystal system examples for the simple cells and body-centered cells structures. The typical examples of tetragonal crystal systems are titanium dioxide and stannic oxide. Next one, rhombohedral, that is trigonal crystal system. We can define the rhombohedral lattice in two ways: as a trigonal lattice with additional translational vectors, or as a simple lattice with primitive vectors of equal length making equal angles with one another. Here, A equal to B equal to C, as well as alpha, beta, gamma equal to not 90 degrees. And orthorhombic crystal system. The orthorhombic unit cell is distinguished by three lines called axis of twofold symmetry, about which the cell can be rotated by 180 degrees without changing its appearance. This characteristic requires that the angles between any two edges of the unit cell be right angles, but the edges may be any length. Next one, monoclinic crystal system. The monoclinic crystal system is one of the 7 crystal systems in crystallography. It is characterized by 3 unequal axes that form a parallelogram prism with 2 pairs of axes perpendicular and the third pair making an angle other than 90 degrees. The monoclinic unit cell also has a single axis of twofold symmetry, which allows the cell to be rotated 180 degree without changing its appearance. More solids belong to monoclinic system than any other, including beta sulfur, gypsum, borax, orthoclast, kaolin, muscovite, clinofibril, clinophyrbol, clinopyroxene, and jadeite, azurite, and spodumene. Next one, triclinic crystal system. The triclinic crystal system is one of the 7 crystal systems in crystallography. It has the least symmetry of all the crystal system and is described by 3 basis vectors of unequal length that are inclined at non-orthogonal angles to each other. The angles between the vectors can be any value as long as they are not 90 degrees. And the vectors do not form a plane. The triclinic unit cell has the least symmetrical shape of all unit cells, with one of the side or angles equal. This is triclinic crystal system. A is not equal to B is not equal to C. Also, alpha, beta, gamma are not equal to 90 degrees. The triclinic crystal system is the most general crystal system, and all other crystal systems can be considered special cases of it. Turquoise and other minerals such as microcline crystallize in the triclinic system. So far, we simply discussed about crystalline structure. Mostly it is 7 crystalline structure and its shape. We have done. Please subscribe our YouTube channel.